world. It's that time again. Bit of assembly language, beginner level. As you might know from my previous video, I'm working on the original Game Boy at the moment. Just making some very simple games. Last time we had this code here, just a simple Hello World project. Now, the beauty of working with this kind of setup with assembly is we can just copy that. If we wanted to keep Hello World, just use that as a donor, we could simply copy it, call it sprite basics. So obviously we're looking at sprites today. Now I could just extend this Hello World, but we've basically got a copy here now. We open that up here. And select folder. We've got the same thing here. Now the only thing that will get you if you try that is if you've copied me exactly in your build folder, you actually want to delete all of that and go back to your assemble script, pop a shortcut in there. That's how I like to do it. Now when I hit that, run it, oh, we've got an error. I think there was an error actually, now I remember. At the end of last video, I had wait for VBlank like that, and I hope you picked up. You probably didn't if you're a beginner like me, but I wanted that to be a local routine to game, and obviously to jump back to it, it needs the dot as well. I think I left that completely. It worked as it was, but game became completely irrelevant. Not, I don't think it's needed, to be quite honest. We don't really need it, but this is the way I've decided to do it. So it goes game dot wait for VBlank and then dot game loop. This is not dot because that's not local to that. It's a different routine altogether. Well, it's not even a routine, it's just some data, a label. Alright, so as you probably know from the last video, this just fills the tile map and it draws it in screen 0, which is the background. And you can change which screen is the background by using this byte here. You can set this up differently, and we looked at that in the last video. You can obviously go back and look at that, or you can look at the pandocs here, which is what I do most of the time. And you know, this is what we looked at last time. So this time is OAM, and that's object attribute memory or something like that. Yeah, object object attribute memory. You can think of an object as a sprite. That's how I work. Sprite and object is the same thing in this Game Boy world. And if you read through this, what you'll find is, I mean, I'm just going to deal with 8x8 sprites. I'm not going to bother with 8x16. Do that at a later date. So every tile is 8x8, and you can have 40 of them at any one time in attribute memory. When you fill each attribute has 4 bytes, so 0 to 3. When you fill all 4 of those, that sprite will show up. If it's, there is a what's the word, like an overscan area on the screen, so if you have it at X position 0, you'll never see it, which becomes handy. And as you can see, it's describing that there. You can do the same with Y. Y equals 0 will hide the sprite, even a 16 size. So as you can see, it's got 16 there, but on the X position, it's only 8. tile index, I mean, that's pretty self-explanatory. Which number of the tile in the tile map or the tile data. And attributes, there if you want to flip it, you can put the background over the top of a sprite and you can set its palette. We won't be doing any of that. The only thing I will be using soon is XFlip. But the rest of it we're going to keep default for the foreseeable future. And really, just as I always say with my videos, I'm only a newbie and I don't claim to be an expert. I just pick up the information that I can and I try and share it. It's designed for people who are perhaps struggling to read through this and they've already had a look. They just want like a simple example, you know, to get going. So that's what we're going to do. So what would we need to do that? Well, the annoying thing with this is, and let's go back to that memory. See where it describes this, what I'm about to talk about. Yeah, writing to the OAM. Now, there's a recommended way, which is writing to a buffer, typically WRAM, and then copy that buffer using the DMA transfer functionality, which is described here. Again, there's no way I can describe this better than the text document, so have a read of that. Essentially, it essentially you can't write to the OAM unless a VBlank is occurring at the time, and I don't know the exact reason for just not checking when it's VBlank and then writing, but I believe that will be too slow. So in order to, you know, write to the full memory at every frame, we use this buffer, and then the buffer upon the VBlank will call that routine and copy data from one section of memory to the actual OAM section of memory. Again, this routine, the bit that was complicated for me was the routine itself has to live in ROM, and that cannot change. It's read-only, obviously, read-only memory. But in order for it to actually know what to transfer, it does need to change, if that makes sense. So like it requires this trick, which I'll show you now. I mean, again, I'm not fully understanding this, to be quite honest, but I understand it enough to show you how it works. And in my opinion, once you know how it works, you don't need to actually understand every little thing about it, if you know what I mean. So I think we'll do that. The very first thing we'll do, I already have a working copy that I'm referring to. Alright, so as you will know from the last video, I've created the Game Boy Helpers file, which is just a load of routines. At the moment it's only got 2, but we're going to have dozens in here eventually. And this is the most complicated one I've dealt with, and even now I've got it in front of me working here on my other screen, and I'm sort of struggling what to show you first. But basically I created another section here called DMA. And let's make it really obvious, like I called it DMA subroutine on ROM. You can call that whatever you want. And that lives in ROM 0. Again, the compiler is going, or the assembler is going to automatically find an address in ROM 0 for me. And if you look at your map file after you have one outputted, which we'll do later, it will show you exactly where it puts that. Anyway, that just needs to define some space of 10 bytes. Because that's how large the routine itself is. So, no, I've just messed up. Ignore that last statement. So we've got our section that we did just define, that's fine. We're going to want some comments up here in a minute. DMA, DMA sub start, that's what I called it for whatever reason. That's where the subroutine begins. Now what we'd like to have is stuff like this: load A C0. So load A with the value of the memory address. Load R DMA A. And if we hover over that, we'll see that's FF46 DMA transfer start address. We can refer back to the pandocs. Not seeing it. Not really seeing that mentioned in the docs. I can't even remember how I arrived at that. But let's continue. And I'll explain it in a second. All of this, what I'm writing here, you're going to need to delete in a minute. So if you do happen to follow along, don't type this necessarily. So we're going to change it. Alright, it's a very straightforward routine. It starts at an address. Now that's just the upper byte, so you can imagine the actual address being 00. Okay. That just wants the upper byte. It just pops it into that section in DMA memory. This is the bit I'm a bit foggy on. And it does that 40 times. I wish I had have studied this a bit more actually before I made this video. Oh yes, I see. That would cause a delay of 160 cycles. It's very confusing stuff. I mean, the way I got around this was I did understand it actually a bit better. Oh, by the way, that does want to be a global variable, a global routine, or label, I should say. But yeah, I did it a bunch of times, and at first I was writing directly into the DMA memory, and it was working fine because I only had one sprite anyway. But this is the recommended way of doing it, so I've been trying to get my head around it. Again, like I say though, once you've got it working, you do, you do, you can survive without not knowing how it's working. All you have to know is it moves that memory fast for you, into sprite attribute memory. Anyway, because it's in ROM, you can't do this. This is illegal on the compiler. It's gonna complain. Let's try and assemble it and see what happens. Oh, well, it actually did assemble. Interesting. Interesting. Okay, okay. Let's paste in the version I actually do have that works just to make sure. We'll see the difference with the comments. These bytes here we're defining, they actually correspond to those instructions that we wrote a minute ago. Dot copy. And for some reason or another, we had to encode these as bytes so that when it gets copied, we copy these bytes into, well, RAM, I guess. HRAM. Just looked it up. So we copy it into HRAM. And for whatever reason, you know, we can't copy load A, C, 0. We have to copy the actual byte that associates to that instruction at each time. Very confusing, but let's delete that and make sure that we got the correct one. Alright. Yes. Nasty confusion, I must admit. I've been trying to figure that out and explain it better, but anyway. Once we get past this, we'll be on the fun stuff of just actually moving sprites around, collision detection, and all that good stuff. So that's going to sit in HRAM. And that one was the one where we do just define space of 10 bytes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. Then we'll call this one the shadow OAM buffer. And that's in WRAM. High RAM is a very small space. From what I've read, it's not any faster than WRAM. However, it allows some more optimized instructions which are faster, which you can't do with WRAM. But for now, at the moment, again, I'm very beginner. I just treat them near enough the same. But for whatever reason, you know, this has to be in HRAM so far. It's all I've learned. I believe it's something to do with like LDH, the instruction. I think there's an instruction called LDH. Look that up if you need to learn more about it. But we're gonna look at it further in other videos. And this one we're defining space of 160, and I wrote it 40 times 4 because each sprite has 4, and you can have a maximum of 40. All right. And that's it. That's it done for Game Boy helpers. Let's just leave it at that. That'll do. Just helps when you're browsing through it quickly. So how do we go about using that? Well, the first thing we're going to need is a sprite itself. I've got one here of a face that I've already made. So back in our main.asm, here you can see we've already made a section for background tiles, and we also made, well, that was it, that's all we made. How about we call this just well, I mean, we can leave that intact, and we can just call this one sprite tiles if we want to. You know, we could have just called it tiles and had them all in there. You know, doesn't really matter. Pasted that in here. Sprite tiles. That's just one sprite for now. A very crudely drawn face. Okay, so with that in place, we're very near being able to display the sprite. Just try and walk us through what we've got that we don't already know about. All of this is fine. Okay. So just for good measure, I'm not sure how important this is, but we're clearing memory. We're using the fill routine that we made earlier. And we're clearing each one of those. As you can see, it says watch out for the stack. We haven't even set up the stack, but basically it's leaving two space for the stack, and I've tried to head scratch over that as well, and I can't quite figure it out. But if you don't include it there, you'll get a white screen. The -2, I mean. I did experiment with not clearing the RAM at all. I didn't see the need to, seeing as we were overwriting it later almost immediately. But it actually did leave me with some weird glitches happening, and then by adding this back, it was very stable. So again, there's a bit of trial and error on my part, I'm afraid. I'm still in two minds about how essential that little section of code is. After we clear the RAM, we want to copy that routine. This is the crux of this lesson, you know, this session. Copy the DMA routine. That'll do. RooTube routine to WRAM. Okay, so why did I choose FF80? It was about a week or so ago I wrote this code, so I'm struggling, but let's try and figure it out. FF80 is the beginning of high RAM. So I've chose that for convenience for myself. So wait, that should actually be into HRAM there. And then point HL at the sub start for DMA. BC we load with the size. So we could just write 10. Well, I don't think we can. We'd have to fill it up to A first. But what we'll actually do is sub end to take away sub start. And then call copy. Simple. So now it's copied into that area. And it's 10 bytes in size, remember? Then we'll keep the background. So that's copying the tile data. Here we actually copy the tile map and we don't note that. And then we'll copy the sprite data. We're going for VRAM block 0 this time. which is where the in the memory map in the tile data, yeah. So block 2 we were using before for the background. If we look at block 0, sprites is 0 to 127 there. So if you change the LCD mode here, down here, you have to use different blocks of VRAM for different tasks. The way we've set it up is the background sits here and then the sprites sit there. So essentially I think this isn't even in use, but again I want to start learning to use the window. That's for like UI overlay and stuff like that. It's an extra type of background that can't be scrolled. And I guess that would go there, but I'm still learning that myself. So that's the reason we chose 8000 hex as the destination. Sprite tiles, same thing again, just load BC with the size. Cool copy. Earlier we disabled one of these here. Disables, I think it's this one. Disables the VBlank, which is what enables us to copy that, that DMA routine and that, as far as I know, you know. But in one of my previous codes, I re-enable that here, but I've actually found I don't need that for this particular task. So I did have like an EI here and a DI above earlier on, and I actually also had a load had a constant for it. That's the internet, the interrupt, whatever you want to call it, register. And as you can see, that's just the value 1 there. That would enable the VBlank again, but I found I didn't need that for this. So at the end of the day, if you don't need it, it shouldn't be there. And of course, normally you will make much better structure in your code. For example, you have a player and an enemy script, and that'll handle some of this stuff we're doing here. But for now, just before the game loop starts, we're just going to create one sprite, create a test sprite, or I don't even want to call it a test sprite. Create show the first sprite on screen as a test only. Yeah, that'll do. And the attributes, again, we've looked at this already, but one more time. So we've got byte 0 is Y, byte 1 X, byte 2 tile, byte 3 flag. So we could look at that like this. Y, X, T, F. That's how I remember it. So Y, X, tiles, flags. The shadow OAM. That's going to confuse you if you didn't listen to me earlier or my explanation wasn't very clear, which definitely is the truth. But you see the value there, C000. I did briefly mention it. That is built into this instruction. So we've hard coded that. You know, we just know that the shadow OEM sits at that address. And you just have to know that. You could change that to that, and then it ain't going to work. You're going to have to change this to this value to be C100. So we purposely chose C0 as our address, basically, for the shadow OEM. That's where it starts to make sense, if you see what I mean. So here I'm just going to do the Y. Look how easy it is to start filling the sprite data now. Just thinking, yeah, let's change that. Right, I've just cocked up completely there. Excuse my English. Because I just tried to load a 16-byte address, a 16-bit address into an 8-bit register, which was wrong. And also, let's use HL, because we're not HL is available, and it has an extra little skill that means I can just go HL plus A, which is going to do load HLA, and then it's going to increment HL afterwards. I'm just going to use 80 for both the X and the Y. Just write Y there. You know what? Let's not use 80 for both. Let's use 70 for that one. So our X. Then tiles. We've only got one. I believe that will be tile 0. You could do X or A, but I'm going to leave it as load A0 because just more clear. You're loading the tile number, tile ID. Rubbish at typing. Same with flags. Flags is also going to be 0 because we don't want to flip it. Okay, the only thing we have to do now is we have to call that DMA transfer routine that lives at FF80. How do we know it lives at FF80? Because HRAM starts at FF80. And let's just try and compile this and see if it shows that on the map. Oh, syntax error. Main.69. Oh, BD. It's supposed to be BC. Okay, we don't even need the emulator open just yet. What I wanted was the map. FF80. DMA subroutine HRAM space. So I already created that section in HRAM and it automatically done it. So like I could have just done FF80. That should work just the same. And yes, it is. So you know what? Why not leave that there and be explicit about it? I mean, you never know. We might declare a section of HRAM somewhere else and it might move that. And if we're not thinking about that at the time, it could be a real source of confusion. Alright, so knowing that it's at FF80, we can literally go cool FF80 if we want to, yeah. And the reason that'll work is because if you look at FF80, the last thing on there is a return statement. So it's going to return. That's why we're calling it like it's a function. And that's why we hard coded it. For some reason we couldn't just write return and have that sitting in HRAM. It wouldn't have worked like that. But now I've actually created a label or a constant just called the DMA transfer routine, so we can call that almost like a method now, or you know, a routine. And actually we want that to happen every frame, so let's just pop that right there at the bottom of the game loop and we're good to go. I don't really like having this map data thing filling up the space there. I kind of don't really like having these sections either. I think I'm just going to have... No, let's leave it. Why am I messing around? There we go. So we have a face. Let's see if it works. It's certainly assembled. I'm having a problem opening the emulator. Okay, so that hasn't worked. Let's have a look at why. It's bound to be something to do with this disabling and enabling of the VBlank. Ah, the stack pointer. I mentioned it earlier. Right at the beginning of our code, we're going to load the stack pointer at the very top of the RAM space. And from reading about the stack pointer, I don't think it really has it here. But somewhere I read about it. When the thing boots up, it decrements the stack pointer by 1. It'll be down here somewhere. Power up sequence. Don't know. Don't know. You'll have to find it for yourself, but essentially it decrements it by 1 at the very beginning. So this is going to start at DFF. So if you write E0, it's going to actually go down to DF like that. So we're then at the start, at the very top end of our work RAM, and it's going to go down from there. If you look, it says Nintendo says use of this area is prohibited. Well, I've actually used it. I've put that to that before, and it did work. But again, it says it's prohibited, so this is not using that area like that. Let's see if that works. Well, we've got our background, but I don't see a sprite there. I actually have a prettier background for the sprite one. Let's just do that for a second for no good reason. Oh, the labels are different, so I can't just copy and paste it, but it's actually a much smaller tile map as well. It doesn't need as much data. Well, that's the amount of different tiles that I just pasted in. Of course, the tile map is the actual same size. Alright, that's going to look a little bit nicer. Okay, so that's the background. We should see a face there. We've got our routine being called. Well, I might have to inspect some memory here. I didn't expect to be doing any debugging. I've moved that up out of the game loop just to see if that helps. Nope, not one jot. Let's move it back. I don't think that'll make any difference. Tile 1, but no, it is tile 0. I mean, I had it on 8080 here, but that's not going to make any difference. Well, I didn't really expect to do this in this video. This wasn't about debugging. It should just work. Let me just study my other code a sec. But essentially, we can look at the values here. C0, that's our buffer. And we can see that 80 is in there for both. The rest of it's all 0. Do you know what? That should work in my opinion. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's our routine that's hard coded. That's in there. VRAM. Where does the actual OAM live again? FE00. Oh god, we've got 3 of them open now. FE00. That's gobbledygook to me so far. Like, why doesn't that match up? I think it must be to do with the VBlank thing. Because you can't write to the OAM during that period. And, you know, unless it's during the H blank or V blank or something like that. And perhaps I was just getting lucky before. Some of my other code I had like this. I did have wait VBlank as a separate thing. Which is a callable routine. Then here, call wait VBlank. I also right at the beginning I don't see how this is necessary either, but let's put it there for now. So what I'm doing there is I'm disabling the interrupts, but if you look, we do the same thing here. So let's put a little question mark there. I don't think it's needed. But we're going to disable the interrupts there, and then we're going to enable them here after copying the sprite data. I mean, we can move data to there, can't we? We don't right into the VRAM block wasn't the problem, but ah, oh no, what have I done? I think right, comment out what I just did. The routine there's fine, we'll leave it. It's nicer like that. This thing here, LCD control FF40 object enable is bit 1, and I've got that as this is why I hate using these OR techniques with constants. Like I have to hover over all of them to see them. Why not just have it's so stupid, I think. What's the point in that? Yeah. I don't know. Maybe when you know it all really well it's okay, but basically I need that like that, don't I? And you know, you can copy this. God, I don't know what I'm doing. There we go. Oh, indent it, you little git. That'll do. Crikey. Now we know forever what all of them do without having to keep going to pandocs. And that's all we're going to need. Let's just delete this. I'm pretty faithful we don't need it. As well as that. Assemble it. No, there's still none. The hell is going on? Let's try it then. There he is, finally. Why is he glitching? That's the first time I've ever seen that glitch. So the only reason I messed around there for 10 or more minutes was that one was a 0 where it should have been a 1. Highlighted one. I really don't understand that glitch. Hmm. I mean, I was going to do another video about oh, sorry about that. My headphones just cut off with no warning. I should have them back now. Yeah, I was going to do a video about basic keyboard input on the character, but none of my example projects when I'm working alone do this glitch. I've never seen that. I also didn't make that same mistake before of leaving that 1 as a 0. So that's wasted me a lot of time, but I really don't want to remake this video. I think we need that. I don't really think we need this VBlank to be its own routine either. Its own subroutine. Because we only need to do that once, that's the reason. We don't need to keep doing it, so why have a routine for it? I didn't think that would fix this glitch though. I wonder what happens if we just move. Oh, could that be the reason? We do the copy just once. Yeah, that does work better. However, we will need to do that every frame, but that's the first time I've ever seen that glitching. Interesting. If we put y as 16 and x as 8, at least I can then detail. I've saved it and assembled it. That is actually the top left corner, look. So the rest of that is overscan. Anyway, that roughly details that, so I'll just pop him down there. And there he is. So at least you've gathered the gist of how to display a sprite by pushing those 4. If we just kept doing it again, I mean I can't really change this face very easily, but we could have another one. Because we're still incrementing HL here, we could just simply copy it. We haven't got any other tiles to use, but we've now got 2 of them, yeah? So that's going to work, and if this video didn't drag on and on and on because of my stupidity, then I was going to include keyboard movement. But to be honest, this is like a bare bones example of drawing a sprite. Let's delete that. This just draws one sprite fixed in a location, and when we want to be able to move the player, it's much better to not have him all in the main.asm here. The way I've done it in my own project is just make a player.asm. It's very easy. Like, I struggled there, but you know, I think partly it's to do with the recording the video. It kind of puts me on the spot more when sometimes I'm just flowing through. I believe it was just the enabling the VBlank there that caused it to not load. Let's have a look. Let's try it without that. Yeah, And this is the same as just writing load A1. Yeah, that, now it doesn't work. Oh, fat fingers. How can that not work when that does? My head's exploding. Now they're there. Ah, I didn't. I've deleted that. What an idiot I am. Just wondering again. Do you know what? To fix that flickering, that was why I did put this into its own routine. And call it from here. And in the game loop. There we go. Hopefully we'll see one now. And he won't glitch. Yes. That's much more like it. Perfect. Finally. So we've learned something there actually. Like, I obviously have learned it before, but I forgot it. Our game loop is going to consist of our halt. It's going to wait for VBlank every frame. And it's going to call the DMA transfer routine. In between this, you'll have stuff like check key input, uh, handle player updates, player or enemy updates, etc. Yeah, perfect. We finally got there in the end. Sorry to beat around the bush with that. Um, the I'll be pushing something like this to GitHub. I think this one can go on there. It's just literally a basic sprite, isn't it? It's not very not that in depth really, the code. I will tidy this up and push this to GitHub so you don't have to type it yourself. At least we know this does work. I don't even use git ignore, so I'll like include all of the build script and everything. You'll have to adjust it a little bit depending on your folder locations. We're all good. We're good to go. Let's give it one more compile just to check before I go offline. It works perfectly. So in the next session, which is going to come up straight after this one, we're going to rewrite all of this and we're going to make it so we can move the sprite around the screen. I'm looking forward to it. Hopefully it'll be a bit smoother than this one. Hopefully you did learn something from this. Please leave a comment if you know anything better, any better ways of doing any of this, or of course if you need help, I'm here. I'm here for you. I mean, I'm not going to be the best at explaining the nitty gritty, but if it's to do with just beginning, I might be able to help you because I'm at the same stage as you are. So yeah, look forward to seeing you again. Look out for my next video, and once I've done all these little simple ones, I'm going to start just building a game on Twitch. That's where I really want to go, just casually, not trying to teach anyone anything because I'm not the best at that. But I felt like these videos need to be there so that I can point people towards them if they do ask. But yeah, we'll fine tune these over the coming weeks and months and make it a lot better and a lot more understandable. Anyway, look forward to seeing you next time. Till then, look after yourselves. Have a very good day. See you soon.